Hello and welcome to the YouTube channel dplyr, and here we learn about data analytics and data science. Data science is an exciting discipline that allows us to turn raw data into insight and knowledge. The goal of this channel is to learn about data science tools and techniques so that we can handle various data science challenges effectively. And today we are going to learn about some of the data manipulation functions from dplyr package of R. So let's begin. Let me start with a simple question. What is dplyr? dplyr is a R package for data manipulations. It is developed by Hadley Wickham and Roman Francois. It is based on a previous R package called plyr. Like plyr, it is also based on the split, apply, and combine strategy. It is one of the most popular package in R for data manipulation. You can learn more about dplyr from the CRAN website. dplyr aims to provide a function for each basic verb of data manipulation. These verbs can be categorized into three categories based on the component of the dataset. For the row level, we have three main functions: filter, slice, and arrange. For the column level, we have four main functions: select, rename, mutate, and relocate. And for the summary of the data, we can use summary functions along with the group by function. But please remember, this is not an exhaustive list. dplyr has more other functions and we can see them in due course. Today we are going to see two functions of dplyr package: filter and slice. Both these functions work in row level. Basically, they create some kind of subset of the main data frame. As you can see, I am using Google Colab to run my R script, and I will start by installing tidyverse package. As you may aware of, tidyverse is a collection of many packages and dplyr is one of them. So now we have our tidyverse package installed and loaded in the environment. So basically, when the filter works, it's based on some kind of conditions, and here is a list of different Boolean operator that work as the conditions. So the general form of filter is that filter takes a particular data frame and then it works on some conditions on different column. So as you know, in tidyverse we have a data frame that is called Star Wars, which is already built in. So I just want to go through that particular data frame and see that what are the different columns and rows, and a kind of glimpse of the data frame that we have. So we have like name, height. So basically these data frame shows the different kind of characters that have participated in different film of Star Wars. So we have different character like Luke Skywalker, C3PO, R2D2, Darth Vader, etc. So, and they have the different kind of characteristic of this individual character, like their name, their height, mass, hair color, skin color, etc. So let's say if I want to say that how many of these characters falls into the droid category. So we have one particular column called species, and then if I say the filter that take the Star Wars data frame and then filter that where the species equal to droid. So we can write it in this way, that filter species equal to droid, and if I run this script, it will give me those characters from the Star Wars that belongs to the species are kind of droid. So as you can see, the species are droid over here. So this is basically an subset of the data frame. But then we can use different Boolean operator along with that. So we have the species equal to droid, and then if I interested, I want to see their eye color equal to red. So then I just put species equal to droid and then eye color equal to red. So we have two different conditions, and I put them together with AND operator here. So then we have a smaller subset of the subset where the chi color equal to red, and they also belong to the species equal to droid. So now you can understand that there is a different way we can use the different kind of Boolean operator to create the subset. So for this example where I try to write that where the species equal to droid and or eye color equal to red, in the previous example we are saying that where the droid who has the color eye color equal to red, but here I'm saying that they give me a subset of the data where either they belongs to the species equal to droid or they could have eye color equal to red. So here you can see that these number of characters from the Star Wars movie, that they either have the red color or they have the species equal to droid category. So here the C3PO who has eye color equal to yo, but it belongs to droid. Or here you have the Note Gunray who has the eye color equal to red, but it not belong to the species equal to droid. It's a different kind of species. So because of this OR operator, we can work differently on two different columns, but then ultimately it gave me a subset. Another example where I can see that where the eye color equal to blue, or I want to see eye color equal to yellow, or I want to see eye color equal to red. So then I can write down that filter eye color equal to blue, or eye color yellow, or eye color equal to red. But as you can understand, if there is more and more options of filtering such way, then I need to write down in OR and OR and OR. And to be very honest with you, that is not very effective way of writing, because the more we try to write that way we can make more mistake. So because of that, in dplyr where we can use that particular in operator, so it's kind of like percentage in percentage, and then we can use a vector. So instead of like or and or and or, if we say that eye color percentage in percentage, and then if we write the vector blue, yellow and red, then it basically says that where the eye color equal to blue and eye color equal to yellow or eye color equal to red. And if I run this code again, we can see that both of them has the same data set. So far we have seen the filter operations is going on all the different column which are having character as their data type. But now we want to see that using the filter functions on those which has a numerical data type. So for example, here is the height. I don't know what is the unit for this height, but it's just I'm saying like where the height is more than 250. So I just simply write that filter height equal to greater than 250, and then it will give me a subset of this character who has, so there is only one particular character, a real poof, which has more than 250. But in a similar way, like we have seen before, we can use the AND operator, and we can say like if any particular character is greater than 250 and weight is less than 220, then we have a subset where they belongs to the height between these two values like 200 and 220. So this is the way we can use and create a different kind of subset of the data. Not only that, like we can even create some other operations in between. So in this particular example, where you want to see to filter the data where the height is greater than the average of the height. So first the system will calculate the average of the height, and the na.rm equal to true means that if there is an na value, then it should remove, and then it will calculate the mean, and after that it will filter out all those which are higher than that mean value. So if I run this script, it will give me this data set. So now I'm a little bit interested to see that what are the which is the mean. So if I just go and copy this, so finally I able to paste it here, but I know I cannot just write the height. I need to write it Star Wars. This way I'm saying that the height column from the Star Wars data frame, and if I run it, it should give me the mean height, and where I can see the mean height equal to 174 unit, and then it should give me all those data that are higher than these. So as we can see clearly that they are higher than the 174, the minimum probably 175. So this is how we can use the filter on the numerical, but similar fashion we can use the filter on the date column as well. So here, since this particular data frame does not have any date column, so I have created a new data frame. So basically this is a data frame which show date from 1st of July in a gap of 7 days, and it will repeat for 26 times, and then it will create a sales column that will create a random value between 300 to 999, and just a round off to 0, and that will happen 26. So this is the way we will create a new data frame. So in this data frame we will have a date column and then a sales column, and then if I want to say that give me those dates that are higher than 1st of October, so if I run it, then you will see that we have October, November and December sales. In a similar, if I say that give me everything between July and October, so if we can write it like day is less than 1st of October 2022, and then we have everything from 1st of July to 30th, because I think that the next one is 7th, so there is no data in between. So this is how we can use the filter functions with higher and greater than or lower than with a date column, but we can also use the between function, as we have seen so far, that we can use greater than on a particular date or lower than a particular date, but we also can use the between function. So if I want to see that all the sales values that happened from 1st of July to 30th of September, so one way of doing it is like when day is greater than or equal to the 1st of July, and then day is less than or equal to 30th of September. But rather than writing that way, I can use the between function. So that way, the simple way of writing is like filter between the day, and then I need to say this is a date, so that's why I use that as date function, and say between 1st of July to 30th of September. Now if I run this script, it should give me the data in between. So yes, as you can see, it starts from 1st of September, and then it's 1st of July to 30th of September. So what I want to say that this is a different way we can use a filter. As I told before, that we can use the filter to create the subset, but that is based on the some conditions. But here we want to see that we can use the slice functions in the similar way, but instead of working on individual column, slice work on the row number. So if I want to see the row number 2, 3 and 8, then I will write in slice 2, 3 and 8. Or if I want to see the row number between 2 to 5, then the best way of writing is the slice 2 to 5. So here I have created another data set, a random data set, which has a team, and then it has a score and the old score. So now we have like from A to H, and they have a score and then score old. And if I want to see only the first row, then I will write it down, the data frame piping sign, then slice equal to 1, slice 1 equal to row 1. So we have the row 1 equal to 8 and 18, so it should give me 8 and 18. And then if I want to see the row number 2, 3 and 8, then the best way of writing is like 2, 3 and 8. But here in this example we want to see that if we want to see the row number, all the records where the row number between 2 to 5, then we can say 2:5. So this is how we can slice. So slice, the main point is slice work on the row number level, whereas filter works on the different conditions of the column, but both will create the subset of the main data frame. So far we have seen all the examples where the conditions are based on some kind of positive sense, in the sense where value is equal to or greater than or equal to, or just greater than or less than or between, etc, etc. But we can also use in a negative sense or the not operator, but the easiest way of using is just put an exclamation signs in front of the column. So the generic syntax of using the not in operator is like filter not column name and then whatever it is. So for say here I have just created data frame which has a name, group and point. If I run it, and then if I want to see that where the name is not equal to A or not equal to B, so basically that way it should give me all the C and D's. So if I run it now, it should ideally give me the 4 different subset like C and D's. But in similar fashions we can say like that where the name is not equal to A and group do not belongs to C. So ideally these 2 will be gone and these 3 will be gone. So we have the name equal to B and group are not equal to C. So we have B and C and then group. But you see that since we have used the AND operator, so that is inclusive both of them. So this is how we can use not in operator. While working on the exploratory data analysis part of a data analysis, a lot of time we need to remove the NA values from the data frame. So one of the straightforward method of removing the NA is na.omit. So this will take the entire data frame and remove all the records where there is any NA value in any of these columns. But sometimes we not really remove all the columns for which content all the records which contain NA values, but we want to remove all those records for some specific column. In that case we use this filteret, or we can also use the is not NA. So here I have created another data frame which is the name of the student, their math score, science score and history score, but sometimes some of the students didn't appear for the exam. For them they have the NA for those exams. So first if I remove the na.omit functions, so then you can see we have here the 6 records. Now we can only have 2 records, that is Brian, because Brian appear in all the exams. So this way like it's removed Ashling because it contained history, NA value for the history, and the second record Ashling because it contained NA value for science, and for Kian it's called NA value for maths. But I'm not really interested for all of them. I want to see where those record for which maths and science doesn't contain NA. So in that case I will write filter at first math and science. I need to specify the name of the column, and then all was is not equal to NA. So this is where it will give me, because as you see like okay Brian is fine, but Ashling also the Ashling is appear in this subset because although it got an NA value for history, but it doesn't have any NA value for math and science. In a similar way, if I I can just work it for one column, but the much easier way of doing it, like if I want to see that history column doesn't contain any value. So in that case, we just write filter exclamation is dot na. So basically, it's not na in the history column, and then we have a subset. So this is how we can use filter, slice, and then filter out different kind of data from the main data frame, and we create the subset for our analysis. I hope you have enjoyed this training, and I hope I will see you soon, and happy learning.